Welcome to Developer Roadmaps. So you've seen how we can structure data in JavaScript, but what happens when one of those data types tries to become, well, something else? Let's find out. Okay, so let's just jump right in with a classic JavaScript head-scratcher. Look at this. On one side, you have the string 5 minus the number 1, and you get 4. Makes perfect sense, right? But then, on the other side, you take that same string 5 and add the number 1, and suddenly you get the string 51? Huh? So, what is going on here? Is JavaScript just broken? Nope, this isn't a bug at all. It's actually a core feature of the language. You see, JavaScript is dynamically typed, and that means this kind of type conversion is happening all the time, often right under our noses, without us even realizing it. So, to really wrap our heads around this, we need to understand that there are basically two different ways, two paths that JavaScript can take to convert these data types. At the end of the day, type conversion is really just changing a value's data type, from a string to a number or whatever it needs to be to get the job done. You'll hear a few different names for it: typecasting, type coercion, but they all point back to the same basic idea. And this happens in two main ways. First, there's what we call explicit conversion or casting. That's when you, the developer, are in the driver's seat, telling JavaScript exactly what to do. Then there's implicit conversion or coercion, and that's when the JavaScript engine itself takes over and makes the decision for you automatically. All right, let's start with that first path, the one where you have all the power. So JavaScript actually gives us a whole bunch of built-in tools or functions to handle this. We've got things like number, string, Boolean, parseInt, and floatpoint. These give us total control over the outcome, so there are no surprises. For example, you can take a string like 42 and just wrap it in the number function. Bam! It's now a real number, and you can do math with it. And it works the other way too. You can take a Boolean value like true and turn it right into its string version, true. parseInt is a really cool one. It's smart enough to look at a string that has both numbers and letters, like 100px, and it'll just grab the number part from the start and toss the rest. Super useful. And this is the big takeaway here, right? When you do this explicitly, your code's intention is crystal clear. There's no guesswork, it's predictable, it's deliberate, and that makes it so much easier for anyone, including your future self, to read and maintain. Okay, so with that in mind, let's go back to that original puzzle. It's time to talk about the other path, the automatic one, called implicit coercion. So coercion is what happens when JavaScript runs into an operation with mixed types, like a string and a number, and it has to think, okay, what do I do here? It makes a judgment call all by itself to make things work. And if you remember one thing from this explainer, make it this. Most of the math operators, minus, multiply, divide, they're all going to try to turn everything into numbers. But the plus sign is special. It prefers strings. It wants to join them together. And that is the key to our mystery. That's exactly why 5 plus 1 becomes 51. The plus sign isn't just for math, it's also for language. The second it sees that string 5, it stops thinking about addition and switches over to concatenation mode, sticking the 1 right on the end. Now, this automatic stuff doesn't just affect math. It also has a huge impact on comparisons. You've probably seen the double equal sign. This is loose equality, and it's kind of dangerous because it'll coerce types before it compares them. That's how you get weird situations where the number 0 is considered equal to the string 0. This is why you should almost always use the triple equals, strict equality. It's safer because it checks both the value and the type. All right, but it doesn't stop there. Coercion also plays a huge role in logic, like in if statements, where basically any value you can think of gets treated as either true or false. So whenever you stick a value inside a condition, JavaScript has to make a call. Is this thing truthy, meaning it acts like true, or is it falsy, meaning it acts like false? So take a look at this. The list of falsy values is actually pretty short and specific. You've got false itself, the number 0, an empty string, null, undefined, and NaN. That's basically the whole list. Everything else in the entire language is considered truthy. And this is where things can get tricky. Look at the right side. An empty array or an empty object. They're truthy. Even a string with just a space in it is truthy. This is a super common trip up for developers, so it's a really important one to remember. Okay, so with all this automatic magic happening behind the scenes, how do we keep our code from getting chaotic and unpredictable? Well, let's get into some best practices. Okay, let's put this on our roadmap. First up, when what you're doing is important and needs to be clear, always use explicit conversion. Use number, use string. Don't leave it up to chance. Second, and I can't stress this enough, always, and I mean always, prefer the triple equals for comparisons. Just make it a habit. It will save you from so many headaches. Third, be really careful with that plus operator when you're mixing types. Always know if you're adding or concatenating. And finally, don't think of coercion as a bad thing. It's not. It's a powerful feature of JavaScript, and once you know the rules, you can really make it work for you. And that really brings us to the core idea here. Explicit conversion, that gives you control and safety. Implicit conversion, that gives you speed and convenience. But knowing how and when to use both, that is what gives you mastery. So now you have a really solid handle on how JavaScript transforms data from one type to another. The next logical step is to see how we can organize all that data. So in our next explainer, we're going to dive into JavaScript data structures, where we'll look at things like arrays, sets, and maps. This is Developer Roadmaps. Map your path. Build your career.